using is multi-homing, right? They typically have a site. Many of our applications every day are depending more and more on connectivity, right? Because we move many of our applications to the cloud, so when connectivity is down, we just don't work, or we don't do what we need to do. So multi-homing is becoming more critical, and so customers use, different connectivity. In this example, via internet or via service provider, could be an LTE plus a DSL, for example, and we lay Lisp over the top so that we can use the overlay independently from the access media that we use. So this is where customers typically get close and get attracted to it. The next step typically is creating small VPN, right? And typically, if you want to interconnect two sites, then the traditional solution of providing connectivity from an ISP not always work, because again, we want different connectivity, we want different access. And so this is where we deploy Lisp as a VPN solution, where we provide connectivity across multiple sites using Lisp virtualization, right? So this customer, the blue customer, is separated from the orange customer somewhere else by the virtualization function that is provided by Lisp. Sometimes this comes together with IPv6, because with the virtualization that we provide with Lisp, we also provide others family independence, right? So IPv6 often comes as a bonus in terms of deploying Lisp. And then, as I said, independence from the access media, right? So it doesn't really matter if one of the sites is connected via the internet or directly through the service provider. So that's the way we virtualize the network, by providing support for multi-tenancy for most of the customers that we have. And together with that, because of the separation of identity and location, we get mobility. So if our device is a small Lisp site, because there is a small Lisp router implementation on the device itself, then it doesn't matter if the device moves through different access, or if it's using 3G and Wi-Fi at the same time. So this is sort of the scenario where we see Lisp deployed. To this, we add the data center portion, right? And again, all the blue sites, this blue dot here, and the data center are part of the customer network. And now, by, again, providing virtualization at the edge of the data center, we can enable VM mobility, right? And here are the use cases that I was mentioning in terms of data center migration or disaster recovery. Moving the application from one site, from one data center to the other, is registered by the devices that are at the edge of the data center and registered to the mapping system. So now the entire network is aware of the location of our application in the data center. And then we can optimize inbound routing, because now this application moves from data center east to data center west to data center east, and the traffic is sent by Lisp directly to the new site. And naturally come cloud extension, right? Because now if we insert a little software router here in the cloud, now we can use exactly the same principle to optimize the routing to the cloud, so to move the application to the cloud itself. So this application here is the use of Lisp at the data center gateway to enable mobility. And this is where we are seeing some very significant deployments at this point. The other example, and I'm done, this will be my last slide, is use Lisp for data center virtualization and to assist an overlay, typically a layer 2 overlay, right? And here, again, we have a similar mechanism where the mapping system is the one providing the mapping between identity and location. In this case, since it is a layer 2 overlay, the identity will be MAC addresses, and the location will be IP addresses. And this will be the tunnel router, or the switches that will provide the virtualization and the support for multi-tenancy. So those are the two areas where we position Lisp for data center application, and this is where we are working, and where we will see more progress coming in the next